Have you ever pondered on the question, what happens if you destroy a black hole? The universe, an expansive canvas of celestial mysteries, is home to one of the most enigmatic phenomena known to mankind, the black hole. A marvel that has piqued curiosity and fostered fascination for centuries. A black hole, in essence, is a region in space where gravity pulls so much that even light cannot escape. The fabric of space and time becomes so warped inside these cosmic beasts that they swallow everything that comes too close, not even allowing a glimmer of light to escape their clutches. They are the ultimate cosmic cul-de-sacs, the point of no return. These celestial entities, the black holes, are not just voids in space, they are the universe's best-kept secret. As we stand on the precipice of this cosmic mystery, we might wonder, what would happen if one were to attempt to destroy a black hole? Now hold that thought, as we dive into the enigmatic world of black holes. To understand what happens when a black hole is destroyed, we first need to understand how one is created. Now let's embark on a cosmic journey, tracing the birth of these mysterious celestial entities. Imagine a star, not just any star, but a massive one, much larger than our own sun. This star has been burning bright for millions, even billions of years, its nuclear furnace fusing hydrogen into helium, helium into carbon, and so on up the atomic ladder. This nuclear fusion releases immense energy, holding the star's own gravity at bay and maintaining a delicate balance. But nothing lasts forever, not even stars. As the fuel starts to deplete, the star can no longer sustain this balance. The outward pressure of nuclear fusion decreases, and the inward pull of gravity begins to win the tug-of-war. The core of the star collapses under its own weight. This collapse triggers a supernova, a stellar explosion so powerful it outshines entire galaxies. But what's left behind is where our interest lies. If the core's mass is sufficiently large, gravity takes over completely. The core collapses further and further, until it becomes a point of infinite density, a singularity. This singularity, shrouded by an event horizon from which not even light can escape, is what we call a black hole. It's a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. These black holes, born from the death throes of massive stars, are the ultimate cosmic Jekyll and Hydes, representing both the end of life and the beginning of a new kind of existence. So, we have a black hole. But what happens when we attempt to destroy it? Before we can destroy a black hole, we need to know what we're up against. Let's delve into the anatomy of a black hole, a cosmic creature that bends space and time itself. At a black hole's outer edge is the event horizon, an invisible boundary beyond which nothing can escape, not even light, the fastest thing in the universe. Imagine the event horizon as a cosmic point of no return. Once you cross this boundary, you're irrevocably committed to the black hole's heart. The event horizon is not a physical surface. You wouldn't bump into it or even necessarily notice when you cross it. It's a mathematical boundary, the point at which the black hole's gravitational pull becomes so strong that escape is impossible. Now, if we dive deeper beyond the event horizon, we find the singularity, the core of a black hole. This is where all the matter that a black hole consumes gets crushed into. Here, density becomes infinite, space-time curves infinitely, and our understanding of physics as we know it breaks down. The singularity is hidden from the outside universe, cloaked by the event horizon. It's a place of extremes, where many of the laws of physics cease to operate as we expect. Surrounding a black hole is the accretion disk, a swirling vortex of gas, dust, and assorted space debris. This disk is heated to incredibly high temperatures by the intense gravity of the black hole, causing it to glow brilliantly. And then there's the immense gravitational pull of a black hole. It's so powerful that it distorts space and time around it. This effect, known as gravitational lensing, can cause light to bend and twist in strange ways, creating a warped view of the universe to an observer near the black hole. Understanding the anatomy of a black hole is vital to envisioning the consequences of its destruction. These cosmic beasts are not just points in space, but whirlpools of space-time, with gravity so strong that it consumes everything, even light itself. Armed with this knowledge, we can now explore the consequences of destroying a black hole. So, what does happen when a black hole is destroyed? Well, to understand this, we first need to delve into the world of quantum physics and introduce an essential player in this cosmic drama, Hawking radiation. Named after the renowned physicist Stephen Hawking, This radiation is a theoretical prediction that suggests black holes aren't as black as they seem. You see, black holes are notorious for their insatiable appetites, swallowing everything that crosses their event horizon. But according to Hawking's theory, they can also leak energy. This happens due to a quirky property of quantum mechanics known as particle-antiparticle pairs. In the vacuum of space, pairs of particles and antiparticles pop into existence and then annihilate each other almost instantaneously. However, near the event horizon of a black hole, one of these particles might fall in before the annihilation can occur, while the other escapes. The escaping particle becomes Hawking radiation. Now here's the twist: the energy for creating these particle-antiparticle pairs doesn't come from nowhere. It's borrowed from the gravitational energy of the black hole itself, so every time a particle escapes as Hawking radiation, the black hole loses a tiny bit of its energy and mass. This process is incredibly slow. Even for a small black hole, it would take longer than the current age of the universe for it to lose a significant amount of mass. But theoretically, given enough time, a black hole could slowly evaporate away, particle by particle, until there's nothing left. So, the destruction of a black hole isn't a cataclysmic event, as some might imagine. It's a slow, quiet process, happening over an almost unimaginable timescale. While the destruction of a black hole may not result in a cosmic explosion, it does lead to some fascinating phenomena. And that, dear listener, is the beauty and mystery of our universe. Now that we've destroyed our black hole, what's left in its wake? Good question. Let's dive into the aftermath of a black hole's destruction. The remnants of a black hole's destruction are as captivating and enigmatic as the black hole itself. As the black hole disintegrates, it could leave behind a range of cosmic phenomena, each as fascinating as the next. Picture a white dwarf, for instance. This stellar remnant could be born out of the ashes of the black hole's demise. A white dwarf is essentially the burnt-out core of a star, left behind after it has exhausted its nuclear fuel and shed its outer layers. It's like a star's final bow before it exits the grand stage of the cosmos. Or consider the possibility of a neutron star. This celestial body is the collapsed core of a massive star that has undergone a supernova explosion. It's incredibly dense, with a teaspoon of neutron star material weighing about 1 billion tons. Imagine that, 1 billion tons in just a teaspoon. These neutron stars are the lighthouses of the universe, rotating rapidly and emitting beams of electromagnetic radiation. And then there's the chance that the destruction of a black hole could spawn another, albeit smaller, black hole. As the original black hole breaks apart, its remnants could collapse under their own gravity to create a new black hole. It's a cycle of birth and death, destruction and creation that's continually playing out in the cosmos. Of course, these are just theories. The truth is, we're still trying to understand the intricate dynamics of black holes. They remain one of the most mysterious and intriguing phenomena in our universe. And the aftermath of their destruction, it's like trying to solve a cosmic jigsaw puzzle with pieces that are constantly shifting and changing. The destruction of a black hole, it seems, is just as mysterious as its creation. So, we've embarked on a cosmic journey, attempting to destroy a black hole and witnessing the aftermath. We've delved into the mysteries of the universe, and we've seen the birth, anatomy, and potential destruction of one of the most enigmatic phenomena in the cosmos: black holes. We've learnt that these celestial bodies are not just simple voids in space, but are complex and fascinating structures that play a crucial role in the universe. The destruction of a black hole, a seemingly impossible task, would have far-reaching implications, causing ripples in the fabric of space-time itself. But even in the throes of destruction, a black hole remains a paradox, a mystery wrapped in an enigma. It's a testament to the vastness and complexity of the universe we inhabit, reminding us of how much there is still to discover. As we continue to explore the universe, who knows what other mysteries we'll unravel?